Hi guys, welcome to lesson 4.2. Lesson 4.2 is going to be kind of an extension of what we talked about yesterday in the previous lesson in 4.1 on graphing equations in standard form. So yesterday we talked about, or in our previous video rather, we talked about graphing things in the form ax squared plus bx plus c. And we talked about how to find the vertex of that, how to set up your table, whether it opens up or down, the y-intercept, and all those kinds of things. So if you haven't seen that video, definitely a good idea to watch that one prior to watching this one. Today we're going to be talking about two different types of equations. We're going to be talking about still quadratic functions, but now we're going to take those forms, we're going to put them in a little bit different form. We're going to put them into two things, one called vertex form and one called intercept form. All right, and so vertex form of a quadratic is a quadratic function written in the form y equals a times x minus h squared plus k. All right, and again, just write it down for now. We'll get into this idea in just a second as we start talking a little bit more about that down here. Our second form is called intercept form. And when we write an equation in intercept form, then we can get the x-intercepts right from the equation. We'll talk a little bit more about how you get those in just a moment here. But again, it's y equals a times x minus p times x minus q. And I don't know why they've chosen p and q for their variables, but that's what they've chosen, so we're just going to use that form. All right, so take a moment, write those down, and let's go ahead and move on. The graph of a quadratic that's in vertex form says y equals a times x minus h squared plus k. Now, I want you guys to think back to our previous chapter about this guy right here. Whoops. We talked about absolute value graphs. This determines basically the slope or the stretch of the graph. Okay, this determined our left and right movement of our vertex. All right, and remember it was opposite. And this number determined our up and down, whether the vertex moves up or down. Now, as we go through this, I want you guys to compare in your heads how similar these situations are. The graph of an equation in vertex form says y equals a times x minus h squared plus k. And the graph is shifted horizontally, whatever h is. And again, because this says minus h, we are going to be doing the opposite of it. And then it's shifted vertically, whatever this k number is on the end. So again, this number inside of the grouping symbols, last time it was inside the absolute value. Now it's just the number inside the parentheses, tells us whether our graph moves left or it moves right. And the k on the end tells us whether it goes up or down. So the vertex then is going to be shifted right or left, however many h is, and then up or down, whatever k is. All right. Now the axis of symmetry, because the vertex exists right at the axis of symmetry, suppose again, here's my parabola, and here's my ordered pair hk that says move it right or left, in this case right h and up k. My axis of symmetry is going to be right here, whatever x equals h is. All right. If a is positive, just like before, if the leading coefficient is positive, it opens up, and if the leading coefficient is negative, it opens down. All right. So let's use that and see if we can't take a look at an example here. Right, so the first thing we're going to be doing then is we are going to be taking a look at some of the key pieces of this equation. The first key piece of this equation is we're going to take a look at that. We're going to identify the constants. A, in this case, is 1/2. The h in here, remember, this says x plus 1, and so to make it say minus, like the previous formula, it should say x minus a negative 1. And so h in this case is negative 1, and k is equal to negative 2. Because a is greater than 0, the parabola is going to open up. All right? And so we're going to then plot the vertex. Remember, this says move it left 1. And so my vertex is at negative 1. And since this says minus 2, that moves it down 2. So remember, we always do the opposite of this number in here. So if it says plus 1, that means we're going to go left 1 for our vertex. Since this says minus 2, we're still going to go minus 2. And so our axis of symmetry is at negative 1. Again, left 1, down 2, that is the vertex for my parabola. Very similar to the absolute value graphs where it was the vertex of my absolute value. My axis of symmetry in this case is going to be at negative 1. And so I'll draw that in a different color here so we can see that. and at -1, that right there is my axis of symmetry. All right, evaluate the function for a couple of values. Now, some things that we get from this, again, we don't get a c value anymore. I want you guys to recognize the fact that this is not y equals, I don't like that color, sorry. This is not y equals ax squared plus bx plus c, where this number is the y-intercept. So this doesn't help us anymore to have this last number to say that's my y-intercept. That's no longer true. All right, but what we can do then is we can say, look, let's pick a couple numbers on either side of this, all right? And so I plug in x is equal to +1, all right? So when I plug +1 into this equation up here, I'll let you guys do the math on it. It is 1/2 times 1 plus 1 squared plus 2, which works out to 0. So when x is 1, y is 0, there's that point. Now, because of the mirror nature of this thing, we know that if x is +1, that's 2 units to the right of the axis of symmetry. If I go 2 units to the left, we also know that we get this point. All right? So again, I get the point 1, 0. Now I'll try like x equals 3. And again, you can pick any numbers you want. You could have picked 0, you could have picked 1, 2, 3, etc. Here we're going to plug in y equals 1/2 times, and we picked x is equal to 3. So 3 plus 1 squared plus, minus 2. And so this becomes 4 squared, blah, blah, blah. This ends up working out to 6. And so we have the point 1, 2, 3, up 1, 2, 3, 4, 5, 6, right in there. Again, because of the symmetrical nature of our graph, this is 1, 2, 3, 4 to the right. So if I go 1, 2, 3, 4 to the left of my axis of symmetry, I'll have that point there. And so now we have our graph going through those points. All right, this is not an absolute value graph. Please make sure that you do not try to connect these like an absolute value graph with a straight line and a straight line. It's not going to work that way. All right. So my picture is probably not the best. Maybe we should make it a little bit more curvy, I suppose. And so we're going to use something a little bit more smooth. So it's more of a parabola feel. But make sure it's not. You're not trying to connect them with straight lines. All right. Top of the next page, then, let's talk a little bit about intercept form. Now, when we look at intercept form, graphing in an intercept form is something totally different. All right, we are not going to come up with the vertex, at least not right away. It says characteristics of the graph y equals a times x minus p times x minus q. The x-intercepts are actually going to be the two numbers p and q. Now notice this says x minus p, so again, if it says x minus 2, that means I have an x-intercept at +2. It's always the opposites of those numbers. And so, sort of like before, remember, if it's in a grouping symbol, it's always the opposite. So like our absolute value was x plus 2, that moved it left 2. And our x plus 3 squared, for example, this plus 3 moves it left 3. Very similar to this, since this is minus p, if the x-intercepts are then the opposites of these numbers. All right? And so, again, the axis of symmetry is halfway between those. Now, let's think about what that looks like. If I have some parabola here, and it has intercepts at p and q, and I don't know, those are two arbitrary numbers, it seems to me then that the vertex is going to be halfway in between those two. So algebraically, what we use to take something halfway in between is we basically say, look, it's halfway between p and q, and so algebraically, how do we find the middle of something? Well, we call that the average. So essentially, we average p and q. We add them together and divide by 2. And that's going to tell you whatever distance this is, or whatever x value this is, that is exactly halfway in between p and q. Again, the graph opens up if a is more than 0, and it opens down if a is less than 0. So let's take a look at an example here. Well, I'm sorry, before we take a look at that example, I want to talk a little bit about why these are my intercepts. All right, remember, the x-intercepts is when y equals 0. So if I rewrite this general equation right here, and I want to find the x-intercept, I get 0 equals a times x minus q and x minus p, or vice versa. I guess they did p and q, whatever, right? All right, we've talked about this thing. Now, first of all, this is not going to change my value, so we're going to ignore that for right now. So this says the product of x minus q and x minus p is equal to 0. Well, in order to get two numbers, let's say, for example, a times b is equal to 0. In order to get a product of 0, that means that either a is 0 or b is 0, right? So the only way we're going to get a product of 0 is if one of these two numbers is a 0. Well, we're going to use that same idea, and instead of using a number, we're using what we call a factor. We're saying, look, this will equal 0 when either x minus q is 0 or x minus p is equal to 0. And so the zeros of this thing, again, what we call the x-intercepts. If I add q to both sides, it's a pretty easy equation to solve. The x-intercepts are at q and p. And so this is, I guess, maybe a proof, but maybe not really a proof. This sort of justification why p and q are my x-intercepts. And this is going to serve us when we get into factoring in about 2 lessons from now. But I wanted to at least make sure I addressed that. All right, so let's graph this quadratic function in intercept form. Again, we said when it's in grouping symbols, it's the opposite. So I'm going to have x-intercepts at positive 1 and positive 5. Here's positive 1, and here's positive 2, 3, 4, 5. Those are my two intercepts. All right, so p is 1 and q is 5. And it's arbitrary which one is which. All right, so the intercepts occur at 1, 0 and 5, 0. Now, to find the axis of symmetry is going to be exactly halfway in between those two. Now, they're 4 away from each other, so I can say it's right there. So I get that the axis of symmetry is at x equals 3. Now, what if they're not quite so obvious? Well, we can take the average of p and q, so 1 plus 5 over 2. And 1 plus 5 over 2 comes out to 6, and 6 over 2 is 3. And so notice right here we get our axis of symmetry at x equals 3. Now, which way does this parabola open? Let's think about that. This negative right here tells me my parabola opens down. So that means my vertex is actually up in here somewhere, so that I get this kind of a shape, right? The question is how high do we put that intercept, and I'm sorry, that vertex? So then we simply plug 3 in for x, right back here, and we get negative 2 times 3 minus 1 times 3 minus 5. And then just a quick bit of algebra. 3 times negative 1 is 2. I'm sorry, 3 minus 1 is 2. 3 minus 5 is negative 2. So you get negative 2 times negative 2. Well, 2 times 2 times 2 is 8. And so you get 8 here. So then we know that our vertex is at, when x is 3, y is 8. And so we go up here 1, 2, 3, 4, 5, 6, 7, 8. And right there is my vertex. And then we can connect those with a smooth curve. And we call that our parabola. Now again, you're going to get much better at drawing your curves. I'm still not very good at it. You can see that that's not the greatest parabola, but you get the idea. If you want to get a couple other points here for your x's, you could certainly plug in, say x equals 2 into this equation and figure out the y value that I'm supposed to get here. I'm not exactly sure I've hit that, but you get the idea. All right? Okay, so we're going to go ahead and take a look then at some checkpoint problems. Go ahead, pause your video, try these couple, and then we'll be right back to go over our solutions. All right, in our first example, again, remember that this number here is opposite, and that tells us which way we move right and left. So since that says minus 3, we're going to go 1, 2, 3 to the right. And since that says plus 4, we're going to go up 1, 2, 3, 4. So I know that my vertex is at 3, 4. Okay, it says label our vertex, so we've labeled our vertex. Our axis of symmetry is then going to be at, well, x equals 3, right? Because we want to know where's the middle of our graph. Well, it's right there at x equals 3. So we've labeled we've labeled our vertex and we labeled our axis of symmetry. Now we just have to find some points around that. So again, when x is equal to 3, that's the middle. So let's pick things like x equals 2 and x equals 1 and x equals 0. And again, those values of x are to the left of my parabola. I'll use those to find the other side. So when x equals those values, what's the value of y? Now, when x equals 2, we plug that in. We get 2 minus 3 squared. Don't forget there's a negative out in front. And then plus 4. 2 take away 3 is negative 1. Square it, we get positive 1. Make it negative. Negative plus negative 1 plus 4 is 3. So when x is 2, y is 3. We plot that point over 1, 2, and up 1, 2, 3. There's our point. Because of the symmetrical nature of our graph, we get to do that too. When x is equal to 1, this is negative, parenthesis, 1 minus 3 squared plus 4. So again, this is 1 minus 3, which is negative 2, but when I square it, it becomes positive 4. Well then, once I make this positive 4, then this makes it negative. So negative 4 plus 4 is 0. So when x is 1, y is 0. And again, because of the symmetrical nature of our graph, we get to go over there. And that seems to be enough points right there that we can approximate a parabola like that. All right, what about the next one? In the next example, we have x minus 4. So that says that I have an intercept at positive 4. And since this says plus 2, that means I have an intercept at negative 2. Remember, they're opposites. When it's opposite, when it's in parentheses or absolute value, if you're going back to our previous understanding from what we talked about before. So we know then that our vertex is going to be halfway in between these two values. So all we do then is we take the average of those two numbers. All right? So to take the average of 4 and negative 2, we then say, all right, well, this is 4 plus negative 2 over 2. And 4 plus negative 2 is 2. 2 over 2 is 1. And so our axis of symmetry is going to be at x equal 1. Now, keep in mind here that your graph is counting by 2's, and so your axis of symmetry is going to be approximately there. Now, which way does our parabola open? Well, again, the leading coefficient here is a 1. It's not a 0, it's a 1. Our leading coefficient is positive, and since it's positive, that means my parabola is going to open up. And so just very quickly, we think our graph's going to look something like this. The question is how far down do we put that value of y? Well, we simply put in our value of x at the vertex, and I get 1 take away 4 times 1 plus 2 when I substitute 1 in for x. And so y is equal to that. This becomes negative 3, this becomes positive 3. Negative 3 times positive 3 is negative 9. And so my vertex is going to be at 1, negative 9. All right, so now let's go ahead and get rid of my original graph here, that is kind of my estimate here. And we'll go something like that. And get rid of that stuff too. And now let's go ahead and place it in the right spot. So when x is 1, y is negative 9. So there's 2, 4, 6, 8. Boy, that was actually pretty close. And then we're just going to go ahead and we're going to make our parabola. So that's the point 1, negative 9. All right. The final stretch of this lesson then is this idea of foiling. Now we've talked about foiling in the past. You should already be familiar with FOIL. But FOIL is an acronym to help us remember firsts, outsides, insides, lasts. All right? And so when we multiply two terms like x minus p and x minus q, for example, when we multiply those two things, we do not simply multiply these two and call it good enough. When we multiply two binomials, we have to use what we call FOIL, which is product of firsts, product of insides, products of outsides, and product of lasts. And so this is first, make the products of the first terms, the outside, and then inside, and then last. And so if I wanted to multiply x plus 4 times x plus 7, I would do the product of the first two. So x times x gives me x squared. Once I've done that, then what I would do is I would go ahead and do the product of the outsides, because the next letter in my acronym is O for FOIL. So I'm going to multiply the outside terms, 7 times x, and that gives me 7x. Then I'm going to do the inside terms, which is going to give me 4 times x, which is 4x. And then the last terms is the 4 and the 7, which gives me 28. From there, we combine like terms. This is x squared plus 11x plus 28. So if I was changing something to from intercept form to standard form, again, standard form is this guy, y equals ax squared plus bx plus c. And so if I want to get it back into that form from this one, which again was intercept form, what I have to do then is I have to FOIL this out and then multiply the whole thing by 3. So we're going to leave this in parentheses. This is going to be x times x, which is x squared. This is going to be x times negative 5, which is negative 5x. I'll just put it as negative 5x. 2 times x, which is plus 2x. And then 2 times negative 5, which is negative 10. From there, we're going to go ahead and combine like terms. This is still x squared. This is now negative 3x, because negative 5 and positive 2 is negative 3x. And then minus 10 on the end. Distribute the 3. We get 3x squared minus 9x minus 30. So now we've just changed that equation from what used to be in intercept form to standard form. All right, so if we want to look at example number 4, we have to remind ourselves first, what does a squared mean? Well, a squared says a number times itself 2 times, right? Because there are 2 of them because of the second power. So if I was going to multiply x plus 2 squared, that is not equal to x plus 2 and then square both numbers inside. This is no good. When we multiply x plus 2 times x plus 2, this means x plus 2 times x plus 2. We have to multiply x plus 2 by itself twice. So we're going to rewrite x plus 2 squared as x plus 2 times x plus 2. Again, 2 terms because we have the same term twice. And so we're going to square that. Now go ahead and FOIL. Again, first, outsides, insides last. You get x squared plus 2x plus 2x plus 4. All right? From there, we're going to go ahead and we're going to distribute our negative 5. So our negative 5 gets multiplied all the way through. Negative 5 times x squared is negative 5x squared. Negative 5 times 2x, excuse me, before we distribute, let's go ahead and combine like terms. This is going to be x squared, this is going to be 4x, and this is going to be 4. Now let's distribute. Negative 4 times x squared is negative 5x squared. Negative 5 times 4x is negative 20x. And negative 5 times positive 4 becomes negative 20. And our last step is to simply combine the like terms on the end. This is negative 5x squared minus 20x and then minus 12. All right, so last 2 problems. Go ahead and try the 2 checkpoint problems at the bottom of the page, and we'll be right back with solutions. All right, so in number 3, we're going to expand this binomial product. So we're going to write this as equals 4 times, and then instead of writing x minus 3 squared, we're going to write this as x minus 3 times x minus 3. Don't forget about the minus 10 on the end. Okay, we're still going to go ahead and FOIL this out in the middle, so we're going to get 4 equals, and when I FOIL x minus 3 times x minus 3, I get x squared minus 3x minus 3x, because again, we do x times x times negative 3, negative 3 times x, that gets me the double negative 3x's in here. And then negative 3 times negative 3 is plus 9. Don't forget you still have the minus 10 on the end. All right. From there, we have to go ahead and distribute that 4. And so the 4 gets distributed all the way through the problem. Right after we combine like terms, I made the same error the last time. This is 4 times x squared minus 6x plus 9. Still have minus 10 on the end. Now go ahead and distribute your 4. So I'm going to slide up over here. This is 4x squared minus 24x plus 36, and we still have minus 10 on the end. When I subtract the 10 from the end, I get 26, and so y equals 4x squared minus 24x minus 26. All right. In the last problem, when we go ahead to simplify x minus 7 times x plus 6, we have to FOIL again. So we're going to do x times x. That is x squared. X times 6, which is 6x. Negative 7 times x, which is negative 7x. And negative 7 times 6, which is negative 42. We still have this negative 3 out in front. Okay, before we distribute the negative 3, we are going to go ahead and combine like terms inside. So we still have only one x squared term. You have 6x and negative 7x, which becomes negative 1x, or just negative x. Still have the minus 42 on the end. From there, we're going to go ahead and we're going to distribute that negative 3. Negative 3 times x squared is negative 3x squared. Negative 3 times negative x becomes positive 3x. And negative 3 times negative 42 becomes positive 126. And so that's the lesson. We should be able to change those equations from either what we call vertex form or intercept form back into equation in standard form. And again, we know certain things about equations in standard form, so sometimes it's easier to be able to go back and forth in between the two. All right? That concludes our lesson.